Good morning, class. This is our last lecture of this chapter, first chapter. Okay. So the last lecture is about laws of conservation. Okay, there are different laws of conservation, and we know that what is actually mean by conservation in physics. Okay, conservation, it gives us idea about in a physical process when a quantity remains changed after the whole process, okay, then that quantity is called conserved quantity. Okay, the quantity which do not alter its value during the physical process, those quantities are called constant quantities or conserved quantities. Okay, so there are different laws, that is laws of conservation, which will give you idea about the quantity which remain conserved during the process, during a physical process. Okay, so first is law of conservation of energy. Number one is law of conservation of energy. Okay, in law of conservation of energy, energy of a system remains conserved. Okay, energy can be transformed, okay, but the whole energy of the system remains constant. Say you have learned in class 9 about mechanical energy, that is total mechanical energy of a body which is falling freely towards the earth's surface. Okay, a body which is freely falling towards the earth's surface, for that body total energy is equal to potential energy plus kinetic energy. Okay, and this remains always constant. The sum is always constant, so there is conservation of energy. Okay, so this is the law of conservation of energy. In case of law of conservation of energy, total energy is conserved. Okay, there is potential energy plus kinetic energy is equal to constant. Got it? Okay, so our next is law of conservation of mass. Number 2, law of conservation of mass. Okay, you all have heard about this equation, famous equation E equals to mc square. This is the mass energy relationship given by Einstein. Okay, so there is a relation between mass and energy. Means in a reaction or in a process, in a physical process, what happens? Some part of mass is converted into energy, or we can say some energy is converted into mass. But as a whole, mass is there and energy is also there. Okay, for a system or for an isolated system, mass remains conserved. Or you can say in a chemical reaction, mass of reactant is equal to mass of reactant. Reactants is equal to mass of the products. Okay, a very small amount of mass is lost due to binding. Okay, due to binding energy. Okay, that mass is almost negligible. So we can say, according to law of conservation of mass of an isolated system is always conserved. Mass is not destroyable. Some amount of mass is converted into energy. Okay, and energy is also converted into mass. They are interconvertible. Okay, and we can say mass of reactant is equal to mass of product. Okay, in a chemical reaction, mass of the reactant is almost equal to mass of the reactant. This is the law of conservation of mass. Okay, our next is law of conservation of momentum. Next law of conservation is number 3 is law of conservation of momentum. Conservation of momentum. Clear? Momentum. Okay. In case of law of conservation of momentum, you have learned in class 9 linear momentum. for a system is conserved. Okay, you have learned that is the initial momenta, that is the sum of initial momenta is equal to sum of final momenta. In case of straight line motion, you have studied in class 9. Okay, getting my point? Law of conservation of momentum states that sum of initial momenta of a body in motion is equal to sum of final momentum. Sum of final momentum. This is called law of conservation of momentum. Now, actually, what is momentum? Momentum measures the effectiveness of a body in motion, or it measures the effectiveness of motion of a body. Okay, how the body is effective when it is in motion. That is the measurement. That is the work of momentum. And when we are considering about momentum of motion of a body, then momentum remains conserved. Okay, that is sum of initial momenta is equal to sum of final momenta. And this law of conservation of momentum is divided into two parts: law of conservation of linear momentum and law of conservation of angular momentum. One is law of conservation of linear momentum. Okay, linear momentum. You will learn in later classes. Okay, later topic you will learn in coming chapters. Okay, you will learn about this in coming chapters. Our next law is law of conservation of angular momentum. Angular momentum. This is for circular motion. Circular motion. This is for linear motion. Okay. So these are the two types of law of conservation of momentum. Now next is law of conservation of charge. Next topic is law of conservation of charge. Okay. Last but not the least, okay. The last law of conservation is law of conservation of charge. Okay. Law of conservation of charge. Okay, this is the last law of conservation of charge, and with this we will wind our first chapter. Okay, we will wind up the first chapter. Okay. Now, according to law of conservation of charge, we know in case of atom there are proton, neutron, and electron. Atom, or we can write atom equals to proton plus electron plus neutron. Okay, these are the subatomic particles. Okay, means the particles inside the atom. That is proton, electron, and neutrons. Okay, so when we consider a neutral substance, then in that case charge is same, means the charge, that is number of electron or number of protons, they are same in case of a matter. If you consider a matter are made of atoms. Okay, so if you consider that atom, then inside that atom protons and electrons are same. But what if there is imbalance in charge, imbalance in this particle? Okay, means if some electrons are removed from an atom and they are transferred to different atom, in that case the atom becomes charged. Okay, means now the atom is not neutral. Okay, say for example this is the atom and we take away some electrons to another atom. This is A, this is B. Okay, now there is a deficiency of 2 electrons. That is, it is +2 charge. Okay, now if these electrons are occupied or these electrons are transferred to another element or another atom B, so there will be addition of 2, there will be excess of 2 electrons. Okay, so this is the imbalance in protons and that is electrons. In this way the charge, that is a neutral substance, get discharged. Okay, means charge flows from neutral substance to, or we can say electrons flow from an atom to another atom. Okay, means we can have charged particles. Okay, but if you consider as a whole, in an isolated system, the charge remains conserved. Okay, the charge can only be transferred from one atom to another atom. Okay, it cannot be destroyed. Okay, charge cannot be destroyed. Charge can only be transferred from a charged body to uncharged body, or we can forcefully charge a body. Okay, we can consider a neutral body and we can apply some external force, that it will be get charged. That is by thermal removing of electron or some other mode. By using electric field, we can remove the electrons. Okay, these are some processes to remove electrons. So in case of low conservation of charge, the charge of the system is always conserved. So this is a system, the charge is conserved. Okay. Okay, or we can say in the universe the charge is conserved. There is no destruction. There is no destruction of charge, or there is no new formation of charge. How much charge is there? That much charge is there. Okay, base charge is conserved. There is no increase and decrease of charge in an isolated system. But if you consider atoms or matter, so we can easily remove charges, or we can easily remove electrons from a matter, and we can transfer that electron to another body. Okay, we can charge it, but as a whole the charge of the system is conserved. Okay, so this is, after this we wind up the chapter number 1. In the next we will start chapter number 2, that is units and measurement. Okay, this chapter is actually not it will not come in exam. Just you have to gain, or you have to keep some elementary idea about these forces, charges. Okay, law of conservation, fundamental forces. Okay, thank you and goodbye. Okay.